Kainatis, welcome. A note in the beginning. We have a special guest today, Professor Darby Dyer. I'll introduce her in a second. But as you notice, I am not starting in Urdu. This conversation is going to be in English, but there will be subtitles below in English, Urdu, and YouTube then picks up and can provide subtitles in whatever language you prefer, Hindi, Punjabi, Balochi, Pashto. You will have subtitles in all of these languages. But let me start with introducing our guest here. And before I do that, I should mention that we keep on talking about Mars. We have two rovers, or actually two countries that have rovers right now on Mars going around. We keep on talking about Mars, but I say enough is enough. We should start talking about other planets as well. And that's why we are here to talk about Venus. So our guest is Professor Darby Dyer. She's a planetary geologist. How cool that is, planetary geologist. She is Kennedy Shelkonoff Professor of Astronomy and Chair of Astronomy at Mount Holyoke College, which is part of the 5-college astronomy department, of which Hampshire is also a part of. She has won many, many awards. She has over 250 peer-reviewed articles. So I can go on and on about that. But I should mention one of her awards, which is the Eugene Shoemaker Distinguished Scientist Medal from NASA Solar System Exploration Research Institute. She's, but apart from all of that, she has driven a rover on Mars. Remotely, she would tell them, okay, which way the rover should go, and the rover would go in that direction. So that's very cool. And I personally had the pleasure of teaching a class with Professor Darby Dyer and a microbiologist, Professor Jason Torr, and the three of us co-taught a class on astrobiology for 3 years. And I think that was a lot of fun. And I'm hoping that students also had fun, but whether they had fun or not, at least the three of us had a lot of great conversation and a lot of learning. I learned a lot from her. So Darby, Professor Dyer, welcome to Kainat.
Thank you, Salman. I am thrilled to be here. Anything for you, my friend.
Thank you. And so let's start with, I mean, we have, I've mentioned Venus missions before, like, that, hey, Venus missions are coming. There are 3 missions that have been announced. But even before we talk about that, I want to know, how did you get interested in astronomy, geology, or science? How did you get into it? What motivated you?
Well, it turns out that I was interested in English in high school. I went to college and decided I would major in art history. And then my college, Wellesley College, required that you take a science course in order to graduate. And so I asked around to find out what the easiest science course was, and it turned out to be geology. So I took a geology course and I was hooked. So I went on to double major in geology and art history, and then ended up in graduate school when I found an opportunity to work on samples from the Apollo missions of the moon. And from then on, I have not looked back.
And so, and I should mention that you have recently gotten more samples from the moon. And so NASA has said, because they are examining rocks that they had brought in the 70s, they're examining them more. So did you get sort of like, big rocks, or did you get a little bit of rocks? What kind of samples did you get from the moon?
So most people don't realize that we only brought back about this, a number of samples about equal to the volume of a refrigerator. So that was out of all the Apollo missions. So the ones that they saved to be opened 50 years later, which they've just recently opened, were just tiny. And in fact, the ones that they sent me are so tiny that in the vial, you can't even see them with the naked eye. They're about 100 microns across, so smaller than a grain of salt. But nonetheless exciting, because they're never before seen lunar samples. So we're pretty excited to get those.
Will you get a chance to sort of like, get a hand on those Chinese samples, the ones that they recently got those rocks, or there's no, I mean, I guess with the US and China, there is no cooperation in that end?
Sadly, no. I think in fact, we're not allowed to use United States funding to study Chinese samples. Now, there may be some informal exchanges, but that's going to have to wait till politics resolve themselves.
It's really unfortunate. So let's talk about Venus. And the first question is like, I mean, really broad one. Why should we care about Venus? I mean, it's a bit uncomfortable. It's a little warm on Venus. So why should we care about our planet Venus?
So do you care about the question of, are we alone? So we know that Earth has life. And I think one of the most important questions in science, philosophy, and the world is whether or not human beings as a species arose on only one planet. And it turns out that Venus is the most Earth-like other planet in our solar system, not Mars. Because as you know, Salman, when a solar system forms, you have a disk of dust rotating around a star, and the star gradually heats up. So the conditions for liquid water start out closer to the sun and then expand outward as the sun matures. So what does that mean? It means that Venus was warm and could have had liquid water on it way sooner than Earth. And there's current models now that suggest that Venus probably had water, liquid oceans, in fact, for about 3 billion years. So you think about that and you think about how long it took life to arise on Earth, and it makes you realize that probably the conditions were right for life to have arisen on Venus. So that's sort of number one, was maybe Venus had life. But even more intriguingly, of course, is the recent discovery of probably millions of exoplanets in orbit around other stars elsewhere in the universe. And the ones that we're discovering, many of them, in part by nature of how we discover them, but many of them are Venus and Earth-like distances from their stars. And so understanding how life might have arisen on Venus is really fundamental to understanding whether Earth is just a special case or whether Earth is just one of a million. And that, to me, is the most important reason why we need to study Venus.
So, I mean, if life or if oceans were there for 3 billion years, I mean, we have sent sort of like, landers, just Soviet Union sent that a while back, and they've been there for a very short period of time. But if oceans were there for 3 billion years, that's a sufficient time for life potentially to have evolved sort of like even complex biology. I mean, not sort of like intelligent beings or something like that, but potentially. And so is that a real possibility that it might have happened on Venus?
It certainly is. I mean, to the extent that biologists like our friend Jason Torr understand how life evolves, certainly on Earth, life evolved on the Earth. And we know that some of the most primitive life forms evolved at mid-ocean ridges, at those vents in nearly boiling water. So we know that life can not only evolve, but also originate in the deep oceans under hostile conditions. So, even if the conditions on Venus weren't hostile, certainly it seems to me as a scientist possible that if the conditions were right, life might have arisen there, and of course might also arise elsewhere in the universe.
So let's, talking about life, let's get the elephant in the room out of the way, and that is about their recent claims that there might have been life in the clouds of Venus. And that was the detection of phosphine, which is not directly life, but an indirect signature potentially. I know that you are skeptical, but I wanted to ask you, what do you think about those results? Because yes, there may have been life in the past, but what about life in the clouds of Venus?
So it makes perfect sense to me that if you have a very high temperature hostile surface, and then you have, the near vacuum of outer space, that there is a gradient between those. And so there is a place between outer space, if you want to call it, and the surface where the conditions are indeed benign. Whether or not life could have ended up there and maybe still existing there, I don't know. I mean, my advisor used to say, show me your data. And if your data are unimpeachable, then you can make whatever conclusions you want from them. And I think these data were acquired with the best of intentions, but people don't realize how many corrections have to be happening between when the data come out of a telescope and when we actually see them in a paper. And I think in this case, they're still unclear on what the proper way to process those data are. So I remain optimistic but skeptical.
And then there were some issues that said some calibration issues, like there
Yes.
was some leakage from other bands that it was detecting phosphine, so it may not have been phosphine as much. So now you are part of the Veritas mission, and I see that you are also wearing sort of like, the t-shirts are already out. So if people want to think about Venus or maybe go to Venus, not soon, but so t-shirts are out. So tell us a little bit about this mission, and also apparently there are a couple of other missions that have been announced. What will it be doing?
So I got started working on Venus many years ago. Actually, in graduate school, I was interested in Venus, but the Venus mission at the time got canceled when I was in graduate school. So that's how actually I ended up working on lunar samples and Mars. So about 15 years ago, it became clear that the clouds which shroud the surface of Venus are not actually completely opaque, that there are tiny slivers of the electromagnetic spectrum between the visible and infrared light regions where you can actually see through the clouds and make a map of the surface. And that's what kind of drew me into this whole idea of sending a Venus orbiter, because as a geologist, when you go out in the field, you need two things. You need a good topographic map so you can locate yourself. And of course, in the old days, we didn't have GPS satellites. The traditional geologist used the topographic map to figure out where he or she was. And then you also need an idea of what the rocks are. And for Venus, we have neither of those things. At the moment, the knowledge of topography on the surface of Venus is less accurate than the knowledge of topography on Pluto, believe it or not. So,
because of the clouds?
Because of the clouds, and because the last mission was 35 years ago. So, it's using technology Magellan used technology that's almost, well, it's probably 40 or 45 years old. So it was, excellent for its time, but very low resolution compared to what we can do now. So in my opinion, because I like to work on fundamental problems, to me, the fundamental first step in going to Venus and eventually hopefully putting a lander down on Venus is you need a topographic map. You need to know where it's safe to land, and you need to know where the cool rocks are so you can land close to them. So the Veritas mission has two instruments on it, and they do exactly those two things. The first one is a radar instrument, which will tell us something about the topography in a very accurate way. In fact, 2 orders of magnitude better than what we had before. And then the spectrometer will map the surface geology and tell us what rock types we hope are on the surface. So those are the two things that we're going for with Veritas. Now, as you noted, there are 2 other missions. One of them is called Da Vinci Plus, and it is a probe which will analyze the composition of the atmosphere as it descends through the surface, and it will eventually, as it clears the clouds, start taking pictures as it descends down to the surface. So it's kind of a one shot, a very slow shot at least, but one shot mission that will traverse the clouds and go down and look at the atmospheric profile to help us understand something about where the water that was once on Venus went. And then the third mission is the Envision mission, which is being supported by the European space agencies. And that will do sort of some of the same things that Veritas will do in terms of taking pictures and doing radar, except that it's more oriented toward close-up. So while Veritas will do 98% of the surface, Envision will look at about 1/4 of the surface in very fine detail. So it's going to be nice that we have this succession of missions, Veritas, Da Vinci Plus, and then the ESA mission, which is called Envision, in roughly within the same decade, but spaced out in such a way that Envision will be able to use the data from Veritas to figure out where to look in detail. So we're really excited about this decade of data that are going to come hitting us in about 5 years.
But no rovers.
No
on
rovers.
Venus.
So I often refer to the triumvirate of things you need to know about Venus, and they include what are the rocks on the surface, what is the atmosphere made of, and what does the surface look like from the surface. So as part of the Venus community, I am trying to encourage NASA to not think about this as a 3 missions and done, but to think of this as the gateway toward putting some kind of a lander on the surface in the next decades to come.
And a small lander. I mean, we were talking before, sort of like lunchbox size, sort of like, lander that goes in. Is it really small, that small lunchbox?
It is that small. So there are a couple of different choices for how you want to put a lander down on the surface. So one of them is that you put something that's very small and that has electronics on it that can handle the hostile conditions, which are 460 C and 93 bars of pressure. So high pressure, high temperature. It turns out that we now have electronics that can handle that kind of conditions for sustained periods up to probably 2, maybe even 3 months. So a long time. On the other hand, if you want to have more sophisticated instrumentation, because you can imagine that on the little lunchbox size one, there's not a lot of instruments that you can put on there, but you can certainly get some, you put cameras and different kinds of sensors, maybe a seismometer on such a little lander, but on a big lander, which would do more complicated things, those we don't quite have the technology to maintain a healthy environment in a giant lander for very long. So when the Soviets did it back in the 60s and the 70s, their landers lasted like an hour or 2. The modern landers, we think at least 12 hours. I was involved in a mission proposal for a lander a couple of years ago, and I think our required mission duration was 5 hours, and then 12 hours if we got lucky, and then maybe 2 days if we got really lucky. So because a lot of these electronics have not yet been tested for a long period of time, and the technology keeps advancing. So depending on when we get the lander selected and flown, I'm hopeful that whether it's a mini lander, a lunchbox, or whether it's a giant lander, that we'll be able to be there for a little more of an extended time.
And I should mention for viewers who don't know, but Professor Dyer is actually a deputy PI, meaning to say she's the #2 person for this whole Veritas mission. So, so you know what you are talking about. And as a geologist, so normally for astronomers, we have these telescopes in the back, but I can see, like, for her in the back, it's a lab. So because a lot of the things are analyzed there, even if you cannot get a sample from Venus, so you can still do a lot of lab work.
Well, in fact, Salman, behind me are 2 Mars chambers. So these are prototypes of the laser-induced breakdown spectrometers that are on Mars right now. So the little one, let's see, over here is a Mars chamber that is very much analogous to the ChemCam instrument on Mars Science Lab. And then the one on this side is a Mars instrument that's analogous to the SuperLibs instrument that's on Mars right now, on Mars 2020. So in fact, we have an even bigger chamber than this at Los Alamos, where we're testing the same instrument, the same laser, to go to Venus for a lander. So we're actively thinking about technologies for analyzing things on the surface of Venus.
Very, very cool. Okay, so we're gonna wrap up, but there are a couple of questions I want to ask you. One is, the last mission or the orbiter mission that was to Venus, it discovered some strange features on Venus, which was sort of like a pancake-shaped features. I am just wondering, what are those? And will you find out more about it? So this was the Magellan mission, I think in the early 1990s, and it had something sort of like, features that we don't know what those are. First of all, I mean, that's really cool to say. We don't know what those features are. So what are those?
Well, I mean, the truth is, Salman, we don't know what any of the features are on Venus, not really, because we don't really know what they're made of. We just don't have enough data. And I'm so glad you picked pancake domes, because those are also my favorite thing on the surface of Venus. And they are exactly that. They're a very round looking volcanic feature with steep sides that looks like one of my favorite old movies describes them as pancakes floating in a sea of basaltic syrup. So that's what they look like. We think that those are made up of unusual lavas that are very rich in silica, because silica makes things very viscous so that they don't flow like a normal volcano would with steep side, with a more tilted sides. So we think that maybe those are low silica lavas, but Right now, we have not enough data to figure that out. So, wait 8 years and I'll be able to tell you.
Very cool. And the other question is, this was asked to me a few, I think a couple of weeks ago, and that was a question about the reason for high winds on Venus, because Venus has pretty high winds. What is causing those?
That's not my specialty, Salman, so I can't answer the question. And they're not close to the surface. They're obviously in the clouds. Yeah. Sorry, that's atmospheres.
Okay.
Don't do
All
atmospheres.
right. Yeah. No, that's because I was like, that's a good question, but yeah, I have a hard time figuring that out. Okay, we are going to wrap up, but before we wrap up, one last question. Since you mentioned a movie as well, but I would like to know what is your favorite science fiction film? And you don't have to be a science fiction fan, so you cannot get away with saying I don't watch science fiction. But from any science fiction film, what is your favorite?
Well, I guess, does The Martian count? I have a special place in my heart for The Martian because the book was so well written and so well researched, and the movie actually kept pretty close to the book. So I like science fiction that is almost real, and I felt like The Martian was almost real. Could almost happen. So that would be my favorite.
Very cool. All right. And as far as I know, The Martian is a favorite of a lot of people who watch this channel. So I think they will be pleased to hear that. Well, thank you very much for telling us about Venus, and we really hope we will find some of the answers about what is going on Venus, and so good luck with the mission. Thank you.
I'll keep you posted.